All right, let's try this. So if we were in class in person, this is what I would be passing out. And so this is the thing that I want you to do on your computer, and then send me the results. So I'll make a little place on Blackboard where you can turn that in. Or actually, let's not send it in to me. Have it for class, and we'll spot check. We can do polls or something like that and see what people got for each of these. But you need to do this page and the next page of the handout and have your answers for that. So you don't have to turn them in on anything, but we will check it a different way. So what we've got here is a protein alignment. And so these are little proteins here, and these are all similar proteins. You're only allowed to put similar proteins in an alignment. So they're going to have similar amino acids and similar overall structure, but there will be differences between them. So a lot of times these will be like the same enzyme from different animals. Like the Y is from yeast and the H is from human, for example. And this is a mitochondrion one, and I'm not sure what the EC is. Maybe an echinoderm, something like that. I don't know. And so what you're going to do is I have put a box underneath a region, and that region is either specifying a beta strand or an alpha helix. And you're going to tell me which. So let's look. So what you're going to do is you're going to go through all these sequences and you're going to make a little tally. So you're going to count up how many amino acids from this group, MALEK. How many of those amino acids do we find in our box? And so our first box is everything stacked on top of this Q down to everything stacked on top of the R. I realize my under boxes aren't as precise as they could be. Second box is from this P all the way to this L over here. So, but not this V. So everything from here to here. Third box is going to be everything from the I all the way to this F down here at the end. And then we're going to have everything from this L right here all the way across to this, let's see. I would say it's that T. So yeah, that column, which has a minus at the bottom. So when you're aligning things, sometimes one is longer than the other, and so you'll put in these little minuses, or rather there are ways that the computer can do this. It'll put in these little gaps to sort of keep everything in alignment and sort of fill in, a space with something, just with a blank character. So you can ignore those. Ignore the little minuses. You're just counting up all the MALEKs, and you're counting up all the TV, WIF, and Ys in a box. And whichever one has the greater total, you're going to write it down. So if we were doing the first column, let's see, MALEK, none. All I see is P's and a Q. MALEK, oh look, LLMLL, so that's 5 total. So I'm up to 5 for this box, and so on. You'll add up your total until you get to the end of the box right over here. And then for TV, WI, F, and Y, you'll do the same thing. So we were on 5 after 2 columns here, and let's see, TV, WI, F, Y, none, none, none. Wow. There's an F and there's a V. So 1, 2, V and F. So we would be up to 2 after 4 columns and so on. So total for the entire space over the box. That is the total number of MALEKs. Not individually, but together, because all of these are going to make an alpha helix. And the total number of TV, WI, F, and Ys, those are going to make beta strands. And whichever one it looks more like, whichever one has a higher total, that's going to be the answer that you put down. So yeah, do this. It's a fun little exercise. And this is, at a very basic level, what computers are doing when they predict protein structure. Only this is a thing that we can do right here with our own hands, which is kind of neat. And so once you have graduated from the easy version, then you're going to do the same thing over here. So MALENK and TV, WI, F, and Y. Forget the YGS and P. Those, yeah, we won't need those for our calculation. So you're just calculating the amount of one or the other in here, and then you're writing all those down. And based on that, whichever total is higher for the box, you're going to call the entire box that thing. And so again, just use your best judgment for where the box starts and stops. Like this one over here would start at this R, and it looks like it stops between the V and the A. So the V is in the box, the A is outside of the box. Yeah. And whatever, if you're off by one, okay, you're off by one. But like down here, it's going to start with this T, and it's going to include this V, I would say. Yeah, that's all for now. Do this assignment, and then let's see how it goes.